Welcome back. This is going to be a continuation of your compound interest notes. Now we will be needing to use the log or natural log to solve the rest of these equations. So we're going to start out with this first one. How long will it take an investment of $1,500 at an interest rate of 2% double? So we're given P is 1,500. If you're not given an initial amount and you're asked how long it's going to take to double, you could always start with an initial amount and then double that. So our A is actually going to be 3,000. You don't really need these numbers to do this problem, but it's helpful to have. The interest rate is going to be 0.02, and it's going to be compounded continuously, so we're going to use the PERT formula. We will do 3,000 equals 1,500 e to the 0.02 times t. Since we're solving for t and we're solving for something in the exponent, we will need to use logarithms. We're going to divide out the 1,500 on both sides. That'll give us 2 is equal to e to the 0.02 t. Now, you can pick your method for solving this. If we switch this to log form and make this log base e of 2 equals 0.02 t, remember you can switch that to ln of 2 and divide. Remember, your other option is to take the ln of both sides because it is an e problem. So we're going to do ln of 2 divided by 0.02, and that's going to give us our time of 34.66 years. That's a long time for that to double because the interest rate is so small. Now you would assume maybe over time you would end up putting more into that investment, or you maybe would invest more than that amount of money. So it may still take that long to double, but at least you would have more money invested. Alright, we're going to go to a next problem though that's going to be a little bit more that we're going to be working with. And here we can use logarithms or ln, but we're going to use logarithms. So how long would it take for an investment of $10,000 to increase to a total of $25,000? We're going to go right into the formula here. So this is our P, this is our A. Compounded quarterly, so we're going to use an n equals 4, and we're going to use 0.035. because that is our interest rate. So we're going to use this formula. So it'll be 25,000 equals 10,000. Whoops, forgot a 0 there. 1 plus 0.035 over 4 to the 4t. Now you want to do some calculations here. We're going to divide both sides by 10,000, so we'll get 2.5 on the left equals, if we do 1 plus 0.035 over 4, that gives us 1.00875. Now, we should write the entire thing out. No rounding here. Now again, you have options. You can switch to log form, you can take the log of both sides. If we switch to log form, remember this part right here is the base. So that's going to stay your base. I'm going to move this, well, keep this underneath. So it'll be log base 1.00875 of 2.5 equals 4t. I'm going to do the rest of the work up here. So it's going to be log 2.5 divided by log of 1.00875 equals 4t. Since we're going to be coming up with an approximate answer for this anyway, you could go right in and calculate the log of 2.5 divided by log of 1.00875. You're going to get an answer of about 105.176 equals 4t. And then you can divide that by 4. Now it's already in your calculator, so just hit divided by 4 in your calculator, and it's going to give you 26.29 years. And you have different options for solving these. If you don't like this method of switching to log form, you can also take the log of both sides and it will accomplish your same goal. Okay, we have 3 more examples to do. Again, we're going to be finding time here. You can use the same method to find rate, which you may have to do on some of the practice problems. For some reason, the ones I picked for the notes are just having you find time, but if you had to find the interest rate or something in an E problem, that would be another place that you could do the logs of both sides. If you're missing something in the exponent, is when you want to do that. All right, so here we're going to be compounding yearly at a rate of, so our n is going to be 1, rate of 5%, so 0.05. And you want 10,000 to grow to 15,000. So we're going to be plugging into this formula. I always like when I'm doing these to write the formula, or I'd have to encourage you to write the formula. Helps you with memorizing it. If you use it enough, you'll get used to it and you won't have to look back at the formula. Again, we're going to do some quick calculations here. We're going to divide both sides by 10,000. So we'll get 1.5. We're going to calculate the inside of the parentheses. We'll come out to 1.05 to the t. And you can, on this one, take the log of both sides just to show that as another option. Remember, you can switch to log form. So if you have questions while you're watching these or after, that's a good time to ask. So this will be a log of 1.5 equals t, if you use the exponent rule, times the log of 1.05. And to solve for that, you would just divide. This will come out to 8.31 years. Next two actually are going to be a little bit different because we're going to be solving for the initial amount invested. So you're going to have to do a full out calculation. Again, if you have, the best option is if you have the ability with your calculator to scroll backwards to do this. Otherwise, you can divide by a lot of the decimal and it'll work out fine. Tanya has just inherited a diamond ring appraised at $5,000. If diamonds have appreciated in value at an annual rate of 8%, so annual, what was the value of the ring 10 years ago when it was purchased? So the $5,000 is actually how much it is now. We don't know how much was invested in that. We know our interest rate is annual, 0.08, n equals 1, and our time is 10 years. When you go to plug this in, write the formula again. It'll be 5,000 equals p times 1 plus 0.08 over 1 to the 1 times 10. So what you're actually going to do is calculate the entire part that p is being multiplied by, so it's 1.08 to the 10th. Type that in your calculator, so put in 1.08 to the 10th. And I'm actually doing this on the calculator as I'm explaining it here just to make sure that I don't forget to tell you anything. I'm writing down what this is approximately. At this point you would divide by 2.16. So you have two options here. You're going to put in your calculator 5,000 divided by. If you hit second negative sign, you can pull that same answer up. Most of you can go back up and select the answer that you just got, hit enter, pull it down, and then divide. Since that's now an option, I feel like that's a little easier. But anyone with the 83 can do the second negative sign for this. And that comes out to be your final answer for your principal or the amount you're putting in. We'll do one more like that, and that will conclude this set of examples. So how much was originally invested? If you have $63,710.56 in an account generating 4% interest, compounded monthly, over 15 years. So we have A is the 63,710.56. Oh, shoot. We have the rate is 0.04, compounded monthly, so our N is 12, and our time is 15. So we're looking for P. Again, we're going to use this formula. Just like before, and I'm going to do this all in one shot, we're going to do 1 plus 0.04 divided by 12, so the 12 times 15. That's going to give us 1.8203, blah, blah, blah. So at this point, you're going to do 63,710.56 divided by second negative sign, or go back and grab the answer, and we get about 35,000. So we have some decimal places, but since we're just going to be doing it to 2, this actually would round to 35,000 even. It's not quite that, but it's close enough. And that's going to conclude the different example problems. So you'll be able to work on some of the practice and finding these different elements of this formula.